Welcome back to Advent Code in BQN. This is my day 2 solution. So this time we go to a red-nosed reindeer nuclear fusion fission plant, I don't know. And there we find a bunch of reports. This is the data. Each line is a report and each number is a level. I am not sure what that means, but what we need to check is if the changing of the levels is consistent. So we need to see if they're either increasing by one, a minimum of one or maximum of three, or decreasing by a minimum minus three and a maximum of minus one. So yeah, let's do that. First, this time it's a bit harder to get the data because last time it was equal, and now we actually need to find spaces and cut on those. I'm not going to go over that. This is the solution already. There are a lot of nice already made split functions in Bacon Crate, and other people made them just to experiment. Tried it myself this time. What it does is just finds the spaces and make a mask where the spaces become minus one and the others become one, two, or zero, one, two, three, four. Each time it's separated. That's what this does. You can read it if you want. And then there's a split function which grabs the I call it tag. You tag them with a number and then groups them by that. So the spaces get dropped, or the character you give it gets dropped, and the others get put in groups. So that's how you then can split text. I'll import the lines from data.text or txt, and we can then split those with spaces. We want to split each. We can actually just show that to see if it's working. Let's clear the last one. BQN day 2, yes. So as you can see, we already have arrays of each number, and that's what we have here. So we have interpreted it right. And then we want to parse float them, and we can do each twice because we go over each list and then each string in the list. Or so there you have it. Or what I chose to do is do depth 1, which makes sure, if I have it correctly, to dig in until you find a unit, which is a number in this case, or actually the strings. I guess a one size or one rank array, which is the strings, and that is where it operates on. So it parses only the strings. Let's store that in D for data. Oh, nice. Okay. So what we wanted to do is find the differences between each step. So we need to be able to calculate a delta. And the delta I calculated with a sliding window of 2. So you get each possible combination. You can see that if I do it for 1, 2, 3, 4. So for 1, 2, 3, 4, you get 1, 2, 2, 3, 3, 4, which are all the possible pairs you can make of neighbors. So we can do that. Oh. But then we don't have the delta, we only have the neighbors. So you want to subtract fold over the cells. So each cell is a row in here. And then we subtract fold them, which means every one you come across, subtract them. That would give you, in this case, minus 1 minus 1. So 1 minus 2 is minus 1, 2 minus 3 is minus 1, 3 minus 4 is minus 1. But we want to swap that. Oh. So that you actually get the delta between the last and the next one. So that's how you get a delta. We can do that with the data, delta data. So delta data, for each line in the data. So now you can already see the steps we are taking. And we need to check if the steps are safe. So if they're inside of that range, which I just mentioned. To get the range, you can write explicitly if it's bigger than 0 or smaller or equal to 3. That means, so it's above 0 and smaller or equal to 3. That's what we needed to check for. So, and now we have a high safe case. So this function now checks if it's going up and safe. We can also check low safe, which you can easily define by high safe with a minus. It inverts the input, so negative values become positive and get a correct value from this, and positive numbers become negative and get a negative value from this. And to check if they're safe in general, safe, we can check if they're either high safe or low safe. And because these functions are, don't know the name, but they work in the whole array, they're going to return a list of all the values if they're high safe or low safe. So we can end fault them. So if they're all high safe or they're all low safe, then they're safe. So let's check if that's working. Show the safeness of the delta D. And that gives us now that everything is safe. I don't think that's supposed to be the case. Oh, this needs to be end, yeah, because it's bigger than 0 is smaller or equal to 3. Okay, sorry. This is fixed now. And now also it's either high safe or low safe. And if we check that, we get all these first ones being true, all these last ones, I mean, the first ones being false, the last ones being true, which is an interesting pattern, but that is the solution. That's what I put in. So we can sum that to see all the safe ones, count up all the safe ones. And that's solution 1. So S1. Shabao, that's solution 1. So yeah, just to go over it, we have a function to split. So we split the lines on spaces, so we get all the individual numbers. We have a function for high safeness, so it's a bit bigger than 0, smaller than 3, smaller or equal to 3. And you have low safeness, which is the opposite of that. And we check if it's either high safe, all high safe, the whole report, or all low safe. Um, and if they're both, then it's a go, then the report is safe. So for problem 2, we found out that there are a lot of unsafe reports, and that was a bit weird. And they remembered there was a problem dampener. So in the case that there was this one step was too big, which made the case unsafe, you can try to take away that step and see if it's still safe. So we essentially need to check if all the cases where one is gone from the report, one of the values, if it might then be safe. So what I did, it's probably not the most efficient way, is to make a function which all one drops, which generates all the versions of a list where one of them is gone. The way I did that is to make a function where you get the values. And within that, we go over the indices of that list. It's called list. Um, so we generate all the indices, we go over them, which means for the length of the array for each index, we create a new item. That's what's getting returned. And here we have access to that index, which is stored in X now, and the list itself. And what we want to do is drop one from the list. So one drop. But we don't want to drop the first one each time. We want to rotate it, do it under a rotate of X. So we rotate the list by X, which moves it essentially to the left, or put the first one to the end and then to the left. So we for each of the item of the corresponding index on the first place, and that's the one we drop, and then we turn it back. So in each case, we drop one version. Let's show what that does for one drop, 1, 2, 3, 4, for example. One drops. So in this case, now 1 is dropped, 2 is dropped, 3 is dropped, and 4 is dropped. That's all the different versions we can have for 1 is dropped. And we can use that to do the same check as before. So solution 2. We go over each data. I should call this report. I like that. So all the reports. Report. Reports. We go for all the reports. We check if the report, which is now X, is or the delta of those is safe. Actually, we don't need to do each because we're already in a specific report. And if it's not safe, so not, sorry. If it's not safe, then we check if the all one one of the one drops. So we generate all one drops of the report, and we check if all the deltas of those delta is safe. And then we order fold, so we have all the different one drops, and then we check if one of them is safe or fault. And if one of them is safe, then we still have a go report because apparently we can allow for one to be dropped, and otherwise it was already safe, so we can just give a one. So here we do the same thing as before, but if it was unsafe, we check if one of the one drops is safe. Essentially, that's all that's happening here. And we can just plus fold that, and that way we add up all the reports. And we can show S1 and S2. Bada bing, bada boom. Those should be the solutions. And again, I have the same code here, but commented, explained. And that's on my GitHub. I really want to do all the days. I'm not sure if that's going to be possible, but these 2 days are really fun. And hopefully till the next one tomorrow.